Now after taking ammonia, let's take now the oxides of nitrogen. We know nitrogen forms number of oxides. Let's take its oxides one by one. The first in the line is its N oxide called N2O or nitrous oxide. This nitrous oxide is having a structure like this one, where this nitrogen is forming a dative bond with the oxygen. It shows the resonance like this. So this nitrogen acquires two lone pairs like this with a double bond, and double bond oxygen with these two lone pairs. So these are its resonating structures. Nitrous oxide is also called laughing gas, but because when inhaled it produces laughing sensation. It is prepared when any of the ammonia salt with nitrate or such strong oxidizing agent is actually heated. It gives nitrous oxide and water. So when ammonium nitrate, it can be easily prepared in the lab, heated, it decomposes to give us nitrous oxide and water. It is a colorless gas. It's a neutral gas, neutral compound. It's not acidic, it's not basic, it's neutral, and it is basically a colorless gas. The second compound, second oxide of nitrogen is NO. It's called nitric oxide. It is prepared when the nitrite salts are treated with freshly prepared ferrous sulfate solution in presence of freshly prepared ferrous sulfate solution with concentrated sulfuric acid. What we find in this case is that what we get is NaHSO4, ferrous gets oxidized to ferric sulfate, we get nitric oxide and water. So these are the compounds obtained, and this is how this NO is obtained, nitric oxide. This is also a test of the nitrite ion. This compound with then ferrous sulfate forms a brown ring at the junction of the sulfuric acid and the solution, and that's the test, that's called brown ring test, which is a test to check the presence of nitrite and nitrate ions. So this is how the nitric oxide can easily be obtained. Now nitric oxide is very special in the sense that it's an odd electron containing species. Therefore, it is paramagnetic in nature. This odd electron makes it paramagnetic. And what you have to realize is what will be its resonating structures, that it can easily, we can locate this odd electron with oxygen also. So it keeps on moving between the two. It's a colorless neutral gas. Again, it is colorless gas and it is neutral in nature, this nitric oxide. Let us take the third oxide of nitrogen, NO2, called nitrogen dioxide. It is obtained by heating any of the metal nitrates which are having their oxides or whose oxides exist, like lead nitrate, which when heated around 400 degrees Celsius, it decomposes to give you lead oxide, NO2. Nitrogen dioxide is a brown colored gas. It's an acidic compound, remember, and its structure is like this. Nitrogen forms a double bond with one oxygen, dative bond with one oxygen, and there is one odd electron here like this. Now this NO2, this nitrogen dioxide, at below 0 degrees Celsius, very easily dimerizes to give N2O4, dinitrogen tetroxide. So at below 0 degrees Celsius, this forms N2O4, and N2O4 on heating forms NO2. Now what you need to understand is that there is this NO2 itself is a paramagnetic species, odd electron containing species. So this again is an odd electron species, and this makes it paramagnetic. But the moment it is taken to what are its resonating structures before letting it to the lower temperature? The resonating structure is that this double bond can be formed with this oxygen also, so we can draw it like this. So there can be dative bond like this one. So these are its resonating structures. Now let us see what happens below 0 degrees Celsius. Below 0 degrees Celsius, the two of the nitrogen dioxide molecules like this one with these odd electrons like this, they themselves combines with each other and forms a bond. So this becomes your N2O4 dinitrogen tetroxide. Remember, it's a colorless, solid, acidic in nature and volatile. Very easily decomposes to give NO2 back. It is diamagnetic. There is a reason, because it's not having any odd electron. So this is how NO2 dimerizes to give you N2O4, and N2O4 on heating forms NO2. The next nitrogen oxide is N2O3, called dinitrogen trioxide. It is formed by the combination of NO and NO2. Both of these are odd electron species. They both together combine to form N2O3. It is almost as like this. This NO2 combines with this oxygen, and they both combine with these two odd electrons and they form a bond like this. So actually it becomes almost like this with a lone pair of nitrogen on this side. So we can have a resonance like this. Sorry, this can be a single bond. So this is the lone pair. So these are the resonating structures of N2O3. Remember, N2O3, most interesting, it's a blue colored solid and acidic compound. That's very special. So what we find is NO2 is brown colored, N2O3 is blue colored. These are the two oxides of nitrogen which are colored. The last of the oxides of nitrogen is N2O5. It's called dinitrogen pentaoxide. It is called anhydride of nitric acid, because when nitric acid is treated with P2O5, it forms N2O5 and metaphosphoric acid. This is how we get this one. It's a colorless, acidic, remember, solid, colorless, acidic, solid, and its structure is the two NO2 type molecular species are combined with each other through a common oxygen. Now we can have the resonance between these in this molecule like this. We can have a single bond here, a double bond here, and rest being the same. So this is how it can show the resonance. So this is what is your N2O5 is, and these all are your 6 nitrogen oxides.